So that's it. So that's why we get jaggedy lines, and that's how you potentially fix them.
No. You didn't think it was going to be that simple, did you? Right. Let's go back to things. So the video signal coming in is a series of fields. So we've got an odd field, and then we get an even field because it's got the even numbers line. So these are referred to as odd fields and even fields. So the computer, when it captures them, is going to combine these into a single frame. Which one are you going to capture first, odd or even?
I'm going to say odd because 1 is odd and there didn't appear to be a 0.
Okay, so we're going to capture the first line first. Right. Video signals don't just have the images that you can see. There's also a whole load of information that you can't see due to the way that the CRT scan things. So there's what's called the blanking and divil. So actually the active picture, the bit you want to capture and display, doesn't start on line 1. It starts on line 20. Now, Sean, is 20 odd or even?
It's an even number.
So which line would you like? Which field would you like to capture first?
I think we should go for even first.
Right, you're an American. So American NTSC video, line 20 is the first one that actually has some picture on it. So when people in America and Japan started capturing video, it made sense to start capturing with the even field. So you take that one and then you take the next odd field and you combine them together to produce a frame in your computer. And then you take the next one and combine them together to produce another one.
Why do I sense there's a but coming here?
Right, now you're in Britain. Video begins halfway through line 23.
Halfway through?
Yes, halfway through. Which one would you like to take first?
I'm going for odd now.
Exactly. So if you're dealing with PAL type video with 25p video, it makes sense, certainly in the SD realm, to take the odd frames and the even frames and combine them to produce a frame. You thought time zones were complicated. And so you get this thing. So before you can actually do any of the de-interlacing, you actually have to know which one of the fields in the frame comes first in time. Because if you don't, it goes in the wrong order. So you display the even field, and then you display the odd field that was before it, then you display the even field, which was 2 fields after it, then you display the odd field that was before it.
That can't look too bad. Can't look worse than the ziggy-zaggy lines at the side of stuff, does it?
Yes. It looks absolutely awful. So, and I'm sure if you try hard enough, you can create some. Or if not, I can send you some video that's actually been encoded like that. So you also need to know, before you can de-interlace it, this is a problem for computers because they tend to store things together. It's not a problem for your TV because it's getting field after field after field. So it doesn't matter. You take one and then the next and you know what you're generating with. But because in computer you've merged them into a single frame in the MPEG video or the QuickTime MOV, they have to store which field is the first one. So it's not that complicated, really, except when people edit videos, they will basically, when you edit something with videotape recorders, you will stop recording and then you'll start going again. And do you stop between an odd frame or an even field?
Depends by the looks of it.
Yeah, there's a switch on your video that tells it which one it's doing on a Betacam machine. So actually you can find that you've captured something in as a continuous piece of video, but actually at certain times, because it was edited on one video machine, you'll have different shots here and here, and at other times you'll have different shots between that one and that one. And so you can't rely on them all being from the same shot, and things get really complicated. Did we mention film? So we talked about film, and we talked about how a piece of film, and I've got some here, captures a single frame of film, and we're going to generate an odd field, and I'm in the UK, so I shall do the odd field first, and then I'm doing an even field here, and I've sort of shown that they're things. So we generate that and that from that, and then we get another frame, we put FR in there, and we generate our odd one, and we generate our even one. So that's that. So in the UK, what we can do, our video is running at 50 Hertz. We'll run film at 25 frames per second. If we're shooting for video, we'll shoot at 25 frames per second. We'll shoot the film at that thing because it's just easier. If it's a film, will speed it up to 25 frames per second because just speed everything up and everything gets slightly higher pitched, but it just works. Now this is great from the computer point of view because if you can combine your odd fields and your even fields and the right thing together, you end up back with your frames being your frames and everything's all hunky-dory. You get it wrong though, and you get the even field and the odd field from the wrong one, and you end up with a blurred mess coming out.
Two images in one.
Yeah. Even though it came from a regressive source and was split up, so you need to get these things together. It's nice and easy with 25 and 50. What about over in the US with NTSC type things? They've got film, and they run it at 24 frames per second, 23.976 if we're going to be accurate. A bit later on, you're going to display the next one, and so on. You need to generate a series of fields. So you generate your odd one, like we did before, like that. And then we generate the even one, like that. We now need to generate the next odd field. And we do that from the next frame. So exactly the same as we had for POW. We generate this one. We now need to generate the next even frame. That's fine. We now need to generate the next odd frame, but actually, in terms of time, we're still at the same amount of point in time as frame 2. So that's frame 2. So we generate a third odd frame from that one. So we now come to frame 3, and we need to generate an even frame and an odd frame. And then we come to frame 4, and we generate an even frame, another odd frame. So this is what you have what's called to the 2-3 pull down, because your first frame becomes 2 fields, the second frame of film becomes 3 fields, the third frame becomes 2 fields again, and the fourth frame becomes 3 fields. Now the problem is that you need to work out where the heck you are in this sequence of fields to work out how to pair them together, which ones to get together. So we've already got the first one, you take the odd one and the even and pair them together. When we get the second one, we've got 2 odds and 1 even, and we could pick either. The next one, we need to take the even frame from one and the odd frame from the other. But remember, the computer's just defined these together. So this is actually 1 frame in the computer, this is 1 frame in the computer, and this is another one in the computer, and so on. So you have quite a nasty problem to try and work out where everything is coming from. So this is why the DVD standard actually enables you to say, actually, no, this is 24 frames per second. You want you to repeat this field at this point in time. So actually you can store it in a much more amenable thing to do that, which makes it easier, provided it's encoded properly on the disk, which it often isn't.